What's up, you freaking geniuses? So in this video, I'm going to teach you how to evaluate functions. All right, so we're going to go over just a few examples, starting with this one right here. So we have g of x is equal to negative x squared plus 4x plus 1. All right, so we want to evaluate three different functions. We want to evaluate g of 2, g of t, and g of x plus 2. All right. So this is pretty straightforward. So as you can see in the original function, we have g of x, right? So we have this x, and then we have x's in our function, right? We have an x there and an x there, right? So if you want to evaluate g of 2, we're going to plug in a 2 right here for x. So that means wherever we have an x, we're going to replace it with a 2, right? Same thing in the equation. Wherever we have an x, we're going to replace it with a 2, right? We're going to put a 2 right there. So g of 2, let's write it. G of 2 is going to be equal to negative, and instead of x squared, we're going to have 2 squared, right? So negative 2 squared plus 4 times x, but again, instead of x, we're going to put a 2 right there, and then we have plus 1 at the end, right? So then here, g of 2 is going to be equal to, let's see, negative, and then 2 squared, that's equal to 4, so this is going to be 4. And then we're going to add that to 4 times 2, which is equal to 8. And then we have plus 1. Okay, so then let's see, negative 4 plus 8, that's equal to positive 4, and positive 4 plus 1 is equal to positive 5. All right, so g of 2 is equal to positive 5. All right, not too bad, right? So let's try just a few more here. Boom, let's get rid of that crap right there. So here, we want to evaluate g of t, right? So that just means instead of x, we want to put a t right there, right? So same thing over here. Wherever we have an x, we just want to replace those with t's. So g of t, and again, we can just write it over here. So g of t is going to be equal to, let's see, negative x squared. So here we're going to have negative t squared plus 4x. So this is going to be plus 4 times t and then plus 1. Okay, now whenever you're evaluating variables in your function, there's going to be times where you can't simplify it anymore, and that's going to be the case for this example. All right, so this is going to be our final answer. Okay, now let's once again take that and throw it away. All right, so now let's do this last one for this first example right here. So we have g of x plus 2. Okay, so let's not overthink this too much. So instead of having just an x in here, we have an x plus 2. Okay, so wherever we have an x, we're just going to replace it with an x plus 2. Wherever we have an x, we replace it with an x plus 2. Okay, so here we're going to say, and I'm going to move it over here a little bit to give us some room, we're going to say g of x plus 2 is going to be equal to negative, and then instead of x squared, we're going to have x plus 2 squared, right? So we're going to have x plus 2 squared, and then plus 4 times x, right? So plus 4 times x, but instead of x, we're going to put an x plus 2. And then lastly, we have our plus 1. All right, now in this example, unlike the last one, there's actually several things that we can simplify. All right, so then this is going to be equal to, let's see, negative, and then x plus 2 squared, well, that's the same thing as x plus 2 times x plus 2. And then we're going to add that to 4 times x plus 2. So here we can just distribute this 4, right? So 4 times x and 4 times 2. So that's going to be 4x, and 4 times 2 is 8, so plus 8. And then we have this plus 1. All right, now this is going to be equal to negative, and then x plus 2 times x plus 2, we can just FOIL that, right? If you multiply that together, you're going to get, let's see, x times x is x squared, and then x times 2 is 2x, and then 2 times x is also 2x, so that's 4x, right? So plus 4x, and then 2 times 2 at the very end is plus 4. Okay, and then here we have, let's see, plus 4x, and then plus 8 plus 1, which we can just combine that as 9, right? So we could just write that as plus 9. Okay, now the last thing we can do here is distribute this negative sign into this set of parentheses. So negative times x squared, that's going to be equal to negative x squared, and then negative times positive 4x is going to be negative 4x. And then negative times positive 4 is going to be negative 4. And then we have our other two terms out here, right? Plus 4x plus 9. All right. Now that we finally multiplied all that crap out, now let's see if we can combine like terms. So let's see, we have this negative x squared, right? So this is going to be equal to, let's say, negative x squared. And then here, let's see, we have a negative 4x and a positive 4x. So those cancel out. And then all we have is negative 4 plus 9, which is equal to 5, right? So here we get that g of x plus 2 is equal to simply negative x squared plus 5. All right, here's the next one that we're going to try. So the function up here is v of r is equal to 4/3 pi r cubed, okay? And the three functions we want to evaluate are v of 3, v of 3 halves, and v of 2r. Okay, so let's start with an easier one right here, v of 3. So again, this just means we want to replace this r with a 3. Okay, so wherever we have an r in our function, we're going to replace it with a 3. Okay, so v of 3, that's going to be equal to 4/3 times pi times r cubed, but instead of r, we're going to plug in a 3. So we're going to plug in a 3 and it's cubed, right? So we're going to cube that. All right, so then this is going to be equal to 4/3 times pi times 3 cubed, which is 27. All right, now here, let's see, we have a 27 in the numerator and a 3 in the denominator, so we can basically simplify that, or reduce that, I should say, down to 9/1. Okay, so here we're left with 4/1 times pi times 9. Okay, now if we simplify this, 4/1, that's just the same thing as 4, right? So here we really have 4 times pi times 9. So combining like terms, we can multiply 4 times 9, which is equal to 36. So then this is equal to simply 36 times pi. Boom. All right, so long, farewell, Alvida, good boy. All right, now this time we want to replace all the r terms with 3 halves. Okay, so this time instead of just 3, it's going to be 3 halves. All right, I know, I'm sorry, it's a fraction. Gross. So v of 3 halves is going to be equal to, first of all, we have 4/3 times pi times r cubed, and instead for r, we're going to plug in right here, right? 3 halves cubed. Okay, so this is going to be equal to 4/3 times pi. Now, in order to apply an exponent to a fraction, you apply it to the top and to the bottom. So here, I'll make it a little bit bigger. We're going to have, on top, we're going to have 3 cubed, and that's going to go over 2 cubed. So then this is going to be equal to 4/3 times pi times, let's see, on top we get 27, and on the bottom, 2 cubed is equal to 8. Okay, now we can once again reduce some stuff here. So just like last time, we have 27 on top, 3 on the bottom, so we can reduce that once again to 9/1. And then 4/8, that reduces down to 1/2. Okay, and don't forget we still have our pi right here. So this is all going to be equal to, let's see, on top we have 1 times pi times 9, so that's equal to 9 pi. And on the bottom, 1 times 2 is just equal to 2. All right, so then we get 9 pi over 2. All right, now you go away. And then lastly, we just have v of 2r. So this time, let's clean this up a little bit. We're going to plug in, wherever we have an r, we're going to plug in just a 2r. Okay, so let's just write that 2r there and 2r there. So v of 2r is going to be equal to 4/3 times pi times 2r cubed. So this is going to be equal to 4/3 times pi. Now, this time you have to apply the exponent to everything that's inside your parentheses. So we need to apply this exponent to the number and to the variable. So we need to apply it to this coefficient, to the 3, and to the variable, to the r. Okay, so if we simplify this now, we're going to get 4/3 times pi times 2 cubed is equal to 8, and r cubed is equal to just r cubed. All right, so now that we applied the exponent to what's inside this set of parentheses, we can basically just drop it. So then why don't we just move this guy over here? So we can rewrite this as 4/3 times pi times 8r cubed. Now, just multiplying straight across, on top we have 4 times pi times 8, so 4 times 8, that's equal to 32, and 32 times pi is just equal to 32 pi, right? So on top, we're going to be left with 32 pi, and also our variable r cubed, so we have r cubed right there, and that's going to be over whatever is in the denominator, which is just 3. So then 32 over 3 pi r cubed is our final answer. All right, let's do 2 last examples. So let's do the one on the left first. So here we have f of y is equal to 3 minus the square root of y, and we want to evaluate f of 9x squared, okay? So again, this just means we want to plug in a 9x squared wherever we have a y, right? So we want to just plug in a 9x squared right there. So that means we want to plug in a 9x squared right here under or inside of the radical, okay? So here we're going to say that f of 9x squared is equal to 3 minus the square root of y, but instead of a y, again, we're going to plug in 9x squared right there, okay? So then this is going to be equal to 3 minus, now here we can actually split up this radical between the number and the variable. So we can write it basically as the square root of 9 times the square root of x squared. Okay, so again, we're splitting up the number and we're splitting up the variable into their own radicals right here. Okay, so then let's simplify this. This is going to be equal to 3 minus, well, the square root of 9, that's simple enough. That's equal to just 3. And then we have the square root of x squared, which whenever you take the square root of a squared exponent, those two cancel out and you're just left with whatever's left inside of that radical, which in this case is just an x. All right, so then we have just an x right there. All right, so this would be your final answer. Now let's go to this last one over here. So we have f of x is equal to the absolute value of x over x. And we want to evaluate f of x minus 1. Okay, so again, wherever we have an x right here, we just want to plug in this thing, x minus 1. All right, so that means we want to plug in an x minus 1 up here and an x minus 1 right there. Okay, so here we're going to say that f of x minus 1 is equal to the absolute value of x minus 1. Let's make those a little bit bigger, all over just x, or in other words, just x minus 1. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.